We're going to go over section 8.2, and we're going to, our objective is to be able to find angles of what's called elevation and depression. So before we do that, let's look at our warm-up, where we want to write an equation that can be used to solve for x, and then we'll solve that equation. So this is what we did yesterday. So as we look at problem A, x looks like it's an angle. And I'm looking, I have the opposite side, I have the adjacent side, and I have the hypotenuse. So I can use any of my trig functions that I'd like to. I'm going to go ahead and use sine just because it goes sine, cosine, tangent. And sine of that angle is equal to opposite over hypotenuse. Now I know to find an angle, I need to find the inverse of that ratio. So I'm going to use my calculator and type that ratio in. So make sure I'm doing second sine to get that inverse up there. And I'm going to do 36 divided by 39. So the angle that gives this ratio would be a 67-degree angle. And I could have also got that same ratio from using any of the other trig functions. Okay, problem B. Again, I'm looking to solve for x. X, when I look at what I'm given, I don't have my opposite, but I do have an adjacent and I have a hypotenuse, which means I can use my cosine function to help me find my angle x. Cosine is equal to adjacent over hypotenuse. So I will need to use my inverse function of that ratio to help me solve and find the angle that it comes from. So I'm going to do second cosine of 12 divided by 24. So a 60-degree angle is going to give me this relationship. Problem C. This time, x is a side. I know my angle. So what is the relationship I have? Well, if this is my angle, x is adjacent. I don't have an opposite, but I do have a hypotenuse. So I'm going to need to use cosine again. But this time I do know my angle, but adjacent is cosine is equal to adjacent over hypotenuse. So I'm going to need to do a little bit of cross multiplying. 1 times x, and then 14 times the cosine of 80. And remember, the calculator has the ratios for cosine of 80 stored. So I'm going to do 14 times the cosine of 80 degrees. So that's going to give me about 2.4. So the side length would be about, let me use about 2.4. Okay, problem D. Again, I do know my angle, but I don't know a hypotenuse this time. So I was given an opposite, not an adjacent, and a hypotenuse, which means I need to use sine. Sine from that angle would be equal to my 12 over x. So if I solve using proportions, 1 times 12, x times the sine of 50. I know to solve for x, I would need to divide both sides by the sine of 50 in this equation. And those sine of 50s are like terms, so they would divide out from my numerator as well as my denominator. So this is going to give me an approximation. So into my calculator, I'd like to do 12 divided by the sine of 50 degrees. So my side would be about 15.7. I'll make sure I round that up. Would be about 15.7. So today we're going to keep using these trig ratios to help us solve, but we're going to be involving what's called angles of elevation and angles of depression. So let's go ahead and look below our warm-up and learn about these a little bit. So it says, now that we know how to find angles and sides of a right triangle using trig functions, we're ready to solve some more interesting problems. When solving more interesting problems, we may need some new vocabulary, which is where our angles of elevation, depression will come in. So let's start by defining what these are. So an angle of elevation is an angle made with the ground and your line of sight to an object above you. So let's say, looking at this picture, let's say you're here on the ground and you're looking up to the top of a building. This would be called your line of sight. And this makes an angle, if we think about the ground, this is called an angle of elevation. So this angle 65 here is my angle of elevation. I'm taking my eyes and I'm elevating them up to the top of this building. We also have an angle of depression. Let's say for some reason you're up on the top of this building and you're looking down at the street. So this time my line of sight takes me down to the street, but now my angle of depression is maybe instead of looking straight out from the building, now I look down, I do as a depression of my eyesight to find that angle of depression. So an angle of depression and an angle of elevation both have a line of sight. Now these lines of sight act as diagonals and form a right triangle. Now, not everything is going to be perfectly right, but we would kind of consider the side of a building with the ground a right angle. And if I was looking out from the top of a building and dropped that vertical side to get down to the point I was looking at, we also know that that would need to be 90 degrees. One thing I want to point out is I could make a rectangle by connecting, well, that wasn't very good. Let me try that again. I can make a rectangle by drawing another triangle that's similar to the one that's given. Now, this angle and this angle of elevation would be considered alternate interior angles. If the top here is parallel to the bottom, then these have to be alternate interior. So similar can happen with an angle of depression. If I create a right triangle, it would come down this direction. Alternate interior angles would be here and with this. So these alternate interior angles can be used. Sometimes a problem may tell you an angle of elevation, but you're trying to find an angle of depression or vice versa. So we'll see how that comes into play in a problem in just a second. So let's go ahead and look at example 1. It says that you are standing 196 feet from the base of an office building in downtown Salt Lake City. The angle of elevation, so there's our kind of key word, to the top of the building is 65 degrees. Find the height of the building. Now, I like to draw triangles, and you decide if that's something you want to do. Let's say you're standing 196 feet from a building. And we'll say, here's my building. Now, normally a building with the ground is going to create a 90-degree angle. And you're looking up to the top of that building. And the angle of elevation to the top of that building, so you're, instead of looking across, you're elevating your eyes and you're looking up at the top of the building. This angle here would be my angle of elevation. And I would like to find how tall this building is. So we solved problems like this yesterday and in the warm-up where we're looking at our angle and trying to decide which trig function to use. So we are trying to find the opposite, and we've been given adjacent, which would tell me to use my tangent function. Tangent of my angle is equal to opposite over adjacent. Still solve it with a proportion, 1 times x, and then I have 196 times the tangent of 65. So my relationship tangent of 65 is stored in my calculator, so I'm going to take 196 times the tangent of that angle. So the height of my building is about 420.3, and we'll make sure we use our units because we're in feet. So the height of my building is about 420.3 feet. So the biggest part about these problems is going to be able to be setting up your picture, being able to understand what it is that you have and what you're trying to find. Let's try it again on example 2. John is standing on the roof of a building that is 300 feet tall. So here's my building, and it's 300 feet tall. So John is on the top of this, and he sees Sarah standing on the ground. So let's say Sarah is over here. He sees her from the top of the building, so his line of sight takes him down to her. If the angle of depression is 60 degrees, how far away is Sarah from John? So John is up here on the top. Sarah is down here on the ground. How far away is Sarah from John? So we're looking to find that distance. Well, this is creating a triangle. The question that what they told us though is an angle of depression. Now, an angle of depression is John from looking up here and looking down. So instead of John looking out across, he's elevating his eyes to look down 60 degrees. Well, this, remember, is creating a rectangle, which means if this is 60 degrees, using alternate interior angles, so is this. So my picture that I drew could work to help me solve for x because these are the exact same angles. I also know if this is 300, so is this. So I could use this triangle up here, but I'm going to use my one that I drew originally. So I'm thinking, what function can I use? I have an opposite and I have a hypotenuse. So this one needs to be sine. The sine from my angle is equal to 300 over my hypotenuse. So I'm going to cross multiply. 1 times 300 is equal to x times sine of 60. I need to do some division. Divide that sine of 60, that ratio, to my other side. So my sine of 60s will simplify, and I'll get about the distance that John and Sarah are apart. So I'm going to take 300 and divide it by the sine of 60. So it looks like they're about 346.4. Let's see again where it looks like we're in feet. So this would be feet away. So 346.4 feet. Okay, let's turn to the back side and look at a couple more. Example 3, a kite has a 25 feet of string. Okay, so maybe if my kite's here, or my person, whoever's holding my kite, then my string, will say it goes up into the air. So my kite's kind of up here. There's 25 feet of string. The wind is blowing the kite to the west. So that the angle of elevation, so if this is the ground, the angle of elevation, it says, is 40 degrees. How far has the kite traveled horizontally? So I'm not looking for how high it is vertically. I just want to know how far it's traveled horizontally. So again, I'm thinking my trig functions. Using my 40 degree, it looks like I'm trying to find adjacent, and I know hypotenuse, which would mean cosine. The cosine of my angle is equal to adjacent over hypotenuse. So we cross multiply. 1 times x, 20 times the cosine of 40. So I use my calculator to help me take 25 times that ratio for the cosine of 40 degrees. So my kite has traveled horizontally about 19.2. Looks like, again, we're in feet. X is about 19.2 feet. Okay, last one. A sledding run is 400 yards long. So we're sledding down a hill, and it's 400 yards. With a vertical drop, so I know if I was at the top of my hill, there would be a vertical drop of about 40.2 yards. Find the angle of depression of the run. So what I've got here is creating a right triangle, but from the top of my run, an angle of depression is created right here, and I'm looking for that. What is that angle of depression, which is the exact same thing as finding an angle of elevation down here. So what would be my angle of depression? Well, I know my opposite and I know my hypotenuse. So sine of my degree is equal to my opposite over my hypotenuse. So this time I'm looking for an angle. So I want to use my inverse of my trig function and type in my ratio from my two sides. So into my calculator, and we'll round to the nearest whole degree. So second sine, and I'd like 40.2 to be divided by 400. So this is not a very big number, which kind of makes sense. We don't want to have too steep of a sledding run, but it looks like if we round to the nearest whole degree, it would be about 6 degrees. So that angle of depression would be about 6 degrees for that sledding run. All right, go ahead and self-assess. How do you feel about solving using angles of elevation and angles of depression? And good luck on your assignment.